Okay, so now we have compound inequalities. These are inequalities where we have two different conditions happening at the exact same time. What happens is we have two different cases when we talk about this. First off, we have the AND case. This is going to be a big deal later, so here's the AND. When we have A and B, we say that that is the intersection between the two. Let's say we have a circle here of information, which is circle A, and circle B. The AND condition means where do they overlap? Right in the middle here. Let's say you wanted to be the manager at a restaurant. And one of the conditions is that you need to have at least 5 years experience of working in a restaurant, and you need to have an associate's degree. You need both conditions. In that case, it would be the intersection. That would be an AND case. The other case is the OR condition, A or B. So that's like we have the two circles again. And we're not just looking where they overlap, but we want all of A and all of B, including where they overlap, but we're not going to double count it, of course. We want everything. Let's say you wanted to apply for a job as a plumber. And there were two conditions. There was experience, and there was an associate's degree. So what happens is, we're now looking for what's called the union, or the OR case. Meaning, you can have experience and still be hired as a plumber, or you can be trained at a college and have the associate's degree to become a plumber. Let's start with an example, talking about different intervals that we can do. We're going to start with the AND case. We got negative 2x is less than negative 8, and we have x minus 5 is less than or equal to 0. Remember, the AND case is like the waiter's job. Both qualifications have to take true. So when I solve this first inequality, I'm going to divide both sides by negative 2. Now remember, when you divide by a negative, that's going to change the direction of the inequality. So it's now x is larger than positive 4. And when I add 5 to both sides of the second part, I get that x is less than or equal to positive 5. Now let's talk about how to graph this. Remember, both have to be true with the AND case. So if we're looking at x is bigger than 4, but less than or equal to 5, let me put down 0, 1, 2, 3, 4, and 5. Now 4, I am not including the endpoint 4, so I have an open circle, but 5, I have a nice closed circle because of the equal symbol. The AND means it has to be where there's overlap. So bigger than 4 goes over to here. Less than 5 goes to the left here. And I'm specifically looking for this overlap here. So my final answer and graph is going to look like so the final answer in graphing notation is just going to be the part where there's overlap. But remember, the endpoints at 5 has to be solid, and at 4 it has to be over the circle here. So there's my final answer in graphing notation. Now we could write it in interval notation as well, and that's going to be a parenthesis to represent we are not including the endpoint 4, comma, 5, with a bracket to show that we are including the endpoint 5. So depending on how the question is asked, either could be your correct answer, either in graphing notation or in interval notation. This next example is going to be the case of or. This is like the plumber with the experience or has a degree. So we're going to have 4x is less than or equal to 0, or 3x plus 2 is bigger than 8. Now I need to solve each inequality. The first one I'm going to divide by 4. So you give me x is less than or equal to 0. Now notice I'm including 0. Or, I'm going to subtract 2. And now divide by 3. To give me that x is bigger than 2. So I now have two conditions. Now this is going to be a little different than the example we just did before. When I go to graph it, the 0 case, I'm going to have a nice solid circle, but I'm going to have everything less than 0. Or, I'm going to have an open circle for the 2, and I'm going to have everything bigger than 2. Notice there's no overlap in this case, but that's okay. The or case, we're not looking for overlap. We're looking for everywhere where we have a solution. So again, we're going to write our answer in two different ways. Our answer is going to first be in graphing notation. And again, we're going to solidly have 0. This graph is actually going to be the exact same as the one above it. That's okay. And 2, or bigger. But we're not including, notice the open circle. Now the interval notation is going to have a union symbol. So we're going to have negative infinity up to 0 with the closed bracket, because we're including 0. Union with, remember the union symbol, because this is the or case. Open parenthesis for the 2, because we're not including 2 as an endpoint. And 2 goes off to infinity. So we have our graphing notation, and we have our interval notation. Please note the difference between the and the or case. You really will need to study the difference between the two. For this last example, the notation that you're going to see is just a little bit different, but we do use it. It's going to be that 6 is less than 5x minus 1, or plus 1, pardon me, is less than 11. And we can actually rewrite this as an and case, actually, just to relate it to what we've been doing before. So 6 is less than 5x plus 1. And versus the or, remember and is the waiter where you need the experience and the degree. Now, instead of solving two different and pieces, we're going to come back to this compound inequality here in the middle. And to get x by itself in the middle, I'm going to subtract 1. But when I subtract 1, I have to subtract 1 from everybody. All three pieces. It's as though I'm solving two compound inequalities at the same time. So I get 5 is less than 5x is less than 10. And now I'm going to divide by 5, but everybody gets divided by 5. Again, I'm solving two compound inequalities simultaneously. So I get 1 is less than x is less than 2. Notice that I'm not including the endpoints in this case. So when I do the graphing notation, my 1 and my 2 are going to have open circles. I was a little uneven there, that's okay. And the in between x means that I want everybody in between, just like that. Now the interval notation is going to be using parentheses specifically because I'm not including the endpoints 1 and 2. This means that x can be anything between 1 and 2. And there you have it.